Rules are for the instruction of fools and the guidance of wise men. But listen carefully. The excuse that people use to justify inaction can say more about their ability and knowledge than how they value human life. Even in regulatory compliance, there are a few individuals that think they can do as they wish. International safety and other standards don't apply to them because they know better. Or maybe there isn't time to go into all that stuff because the customer wants the product now. Or then again, it's going to some third world country, so no one really cares. The sad truth is that a designer doesn't need to go out of his way to kill people. Any designer that is unaware of safety and other regulatory guidelines will inevitably design a product that kills. So pick up your pen and write down the answers to the following questions, and no cheating. It's never done that before. This is one of the most common reasons for ignoring regulatory compliance, and particularly safety. It comes invariably down to, we've been making these for years and we haven't killed anybody yet. To an extent, that argument is perfectly sound, perfectly correct, and perfectly reasonable. Statistically, the probability that a new, even non-compliant product will kill somebody is initially low. But that probability will change as components wear out and begin to fail. For example, in most safety standards, there's a requirement for 2 levels of protection between the operator and a hazard. So let's take insulation. Basic insulation plus supplementary insulation provide those 2 levels. So a non-compliant product which has only basic insulation between the operator and hazardous voltage will be safe until that basic insulation fails, and then the operator may receive a fatal electric shock and die. The question is not if the basic insulation fails. Basic insulation is expected to fail during the life of the product, and that's why it's called basic. Before we go into details of how and why products cause death and injury, let's just make a simple analysis of a real-life situation. Most of us will already have seen these photos on the web. We're going to explore how things can go badly wrong when something out of the ordinary happens. Then later on in part 2 of this blog, we'll turn that into an everyday product and see how standards protect us, or conversely, how non-compliances create hazards. Releasing a bear is easy. Chuck's done it hundreds of times. But there are risks. There are significant forces at play, and there are things that can go wrong. So what are those risks? What are the magnitude of the forces, and what could go wrong? How could those risks be avoided? And what's missing from this photo? What are the risks? There is no electrical supply, and we'll ignore the chemical and environmental issues because we're not going to export this to the EU. So the only hazards remain are mechanical. The container can slide about or even out of the back of the truck. It could tip, it could topple, it could fall, it could crush, or the operator could get trapped in the door. And what could we do to prevent the hazards? Well, we could strap the container to the truck. We could fit an automatic remote latch to the door so that it can be opened remotely when at safe distance away. And what are the forces that could act on the container? There's centrifugal as the truck turns around a corner. There's friction between the container and the bed of the truck, which is what keeps it in place when it's going around a corner and not tied down. And there are static forces. Let's just take for argument the weight of the container to be 300 pounds, the bear to be somewhere between 500 and maybe 3,000 pounds, and the operator of 250 pounds. We're going to look at an impulse or dynamic force, which is going to be about 3 to 4 times the static. The question is now for you to calculate the forces that might come into play. Think of things like, how high could the bear Chuck if the brown bear would Chuck? What else can happen in Chuck's encounter with the bear? Will Chuck survive? And could safety standards have had any impact upon this situation had they been applied? We can also look at the relevance of standards which are not applicable, like 950. Would that have had any benefit in this scenario? In the next part of this blog, I'll give you my ballpark figures, and please compare them with your own. See which of us is nearer. There are no right answers. There are only wrong answers, not doing anything about a situation which may occur. Model the situation and determine the risks and the solutions to those risks.